we have designed an augmented digital whiteboard system called Flatland. When a user begins writing, the system automatically creates a new region called a segment, which groups together related sets of strokes. The process is as easy and lightweight as writing on a real whiteboard. If the user draws a stroke in an open area, a new segment is created. The boundary of an active segment turns green and expands a bit to make space to write in. Users can also manually join and split segments. Segments are not allowed to overlap. If a segment hits another segment, it is pushed away. If no more space is available, the segment starts to shrink. Behaviors alter the way a segment behaves in a task-specific way. Here is a to-do list behavior. The user can add, reorder, and delete items. The map behavior aids in map drawing. Every stroke turns into a street, and intersections are processed appropriately. In contrast to standard applications, behaviors can be flexibly removed and reapplied. Here, the user has drawn some freehand strokes, and then applied a 2D drawing behavior which helps beautify rough strokes and can predict the next parts of a drawing. We are working with context-based searching behaviors. These behaviors allow the user to retrieve a past segment based on the context of its use, including its time, color, location, and so forth. This video has presented our work on a computationally augmented whiteboard designed for office work. Based on studies of actual whiteboard usage, we have designed Flatland to support common needs, such as space management, support for common tasks, and history management.